This is a high school Algebra 1 lesson on linear regression. Professor Frog here will assist me occasionally just because I like doing that. I want to mention that this is not really the real thing. What we're talking about here is we're talking about general terms, learning kind of what it's like, what we're talking about, how it kind of works. You're going to get the real thing later on in advanced placement statistics or in college, maybe before, depending upon what types of courses that you take. And there'll be lots of equations and lots of detail and lots of specificity. Well, we're not doing that. We're just kind of doing generally. So let's start here with one of the terms of linear regression. One is interpolation and another is extrapolation. Okay, interpolation. Finding the values between the values that you know. Extrapolation. Finding the values that are beyond or outside of, might be before, outside of the known range of the stuff that you know. Okay, you're talking about, okay, well, what are you talking about? Well, here, let me get a graph to help. And I'll make a little first quadrant graph here. And then we're going to need some data. Okay, well, what am I going to do for my data? I'm thinking, well, you all just heard Ollie bark. So we'll talk about dog food, because when you got dogs, you get to have lots of dog food. So we'll talk about how much the dogs weighed, the weight of the dogs, and that's going to be in pounds. And then the price of the dog food. So, how much do I have to pay Amazon to come dump the blue dog food on my doorposts? Okay. Well, I'll get all kinds of like how much this dog weighs, how much the food that they eat, and how much the food they eat counts. And I'll do that, and that dog eats that has a lot, and that dog doesn't eat much. We call those outliers. They don't fit in kind of with the rest of them. You'll notice there's kind of a trend here. We did trend lines. And so let's say that's our data point. We check up on like how much it costs. Amazon come set it on my porch. And some of it, maybe it's on sale and it's a little less, or maybe the dog didn't feel like eating, or maybe I gave him too much of the stuff. Okay, and so we'll have something like that. That'll show generally what the data is. So each one of these dots, this would represent a certain weight of dogs, or dog, and a certain price of the dog food that I have to pay for them. So here, the x-axis is the weight of the dogs, the y-axis is the price of the dog food. So if it's 5 pounds of dog food and it costs $4, then it would be like someplace like right here. Okay, somewhere it matches up. That's what each point represents. Okay, what we're going to do here is we're going to draw a line of best fit. We talked about the line of best fit. And what's it going to look like? Well, let's see. Remember, it needs to be about in the middle of it. And one of them needs to be better than the other. Like I could put it here, half is above, half below. Now that's no good because it doesn't really show us the trend. Okay, something like that, I'm guessing, is what the trend would be. So I'll go ahead and draw my line of best fit and hope it's a best fit just about right there. Okay, so that's going to be something about like this. Okay, let me see. Okay, so let's see. Ollie, who you just heard barking, and Jasper, who's usually sitting under here, but he's not. He's around somewhere. Maybe he'll come and bark. He's the one with the lower voiced bark. So we might have some certain things, and I'm not doing this real specific. This is just general, sort of like that kind of stuff. Okay, so let's say Ollie and Jasper together weigh about 80 pounds. They're a little bit less than that, but that's an easy number. So let's say 80 pounds of dog and how would I find out how much the cost is? Okay, what this line of best fit is telling me what I should expect in general to pay for the dogs if there are that much of them. Okay, now you'll recall that we can use graphs when we know one to find the other. And so I'll start at 80 pounds a dog, and I'll draw up to the intersection of my line of best fit, and then I'll draw over to the price, and let's say the price is about $60. That's about right. That's how much Blue Buffalo gets for their food. Okay, now I used to have bigger dogs. Yeah, Percy and Maisie, and before that, Maisie and Sadie. So together I had, about 160 pounds of dogs. So let's say 160 pounds of dogs is going to be about right here. I'll do the same thing. 160 pounds a dog. How much should I expect to spend on dog food? Draw it up to the line. There's the intersection. Draw it over to find out how much I should expect it to cost. And I should expect it to cost, let's say, $120. Yeah, keeping dogs in this. What do you bet? Keeping them in dog food is enough, but keeping them in those pesky heartworm pills, now that's something else. Okay, so for 160 pounds, I'd expect it to cost about $120 for the dog food. Okay, so now let's talk about interpolation. Interpolation is finding the values between the ones you don't know. These are the ones that I'm given. Okay, and that's what I should expect. So what if I was thinking about a change in dog? Maybe I was going to get a little one, and I'm going to get a total of 120 pounds of dog. I'd do the same thing again. I'd say, well, about how much should I expect to pay for the dog food? This is between. This is hypothetical. Now I'm going to see where on the line it is. I knew the value 80 and 160. I knew the value 80 and 160. And now a value that I don't know is 120. And I'll look over here. And if it really is proportional, which I've made it that way, then I would expect to pay $90 for the dog food. This is interpolation. I knew the value for 80 because of Ollie and Jasper, and I knew the value for 160 because of Percy and Maisie, and so I wanted to know what should I expect in between. Okay, that's interpolation. Interpolation is values between the values that you know. So that's what I would expect. I would expect it to be about right there. Okay, well, what about past what I don't know? What if I'm looking at, say, 200? That's past almost of my data here. And so if I'm looking for 200 pounds of dogs, that's a lot of dog. Okay, then I would do the same thing. Now this is past my range of my data. There's a few there. I probably shouldn't have drawn them quite that far off. There's a few of them there. Let's say 200. Well, then what I would expect, do the same thing. Figure it out. I am now extrapolating. How about way out here? How about, I don't know, 300, where there's really got lots of dogs, going to have to get a kennel license. We'll put it out there, and we'll see, and we'll extrapolate, or we'll try to find values outside the known range. We use our line of best fit to help us with that. So interpolation is finding the values between the values that you know. Extrapolation is finding values outside the range, attempting to predict what it would be. Okay? So now let's look at correlation. We've talked some about correlation. We have a positive correlation and a negative correlation. In a positive correlation, both indicators change in the same direction. Pretty much always, if one goes up, the other goes up. There are some circumstances where down and down works, but you're working with it kind of weird when you're doing that. So we'll talk in terms of up. Say the value of frog goes up. The value of dog goes up. If one goes up, the other goes up. They might even hold hands. If one goes down, the other goes down. Same direction. The indicators, whatever I'm measuring or whatever I'm observing about frog and dog, if one goes up, the other goes up. If one goes down, the other goes down. Again, pretty much all the time when with things that we're doing, it's going to be both going up. Okay? So there we go. They move in the indicators, whatever we're dealing with, move in the same direction. That's called a positive correlation. The dog food, the weight of the dogs and the price of the dog food was a it was a positive correlation because you get more dog, you got to pay more for dog food. So that's an example of a positive. Okay. What's an example of a negative? So a negative, one would be going up, the other comes down. They move the opposite directions. Okay? One goes one way, the other goes the other way. Frog and dog. One goes up, the other goes down. One goes up, the other goes down. Okay, well, let's say you want to buy something, and you've got some money in your pocket. Okay? So the money you've got in your pocket, how does that work? So let's say you go to the store and you've got $100 to spend. Okay, so you got $100 to spend and you want to buy a bunch of candy. So when you have $100 and you've bought no candy, this is in your pocket and this is in your tummy. Don't eat your money. Not a good idea. Okay, so you've got, that's running out of ink. So you started with $100 and you only have, and you still have $100 in your pocket. How much candy do you have in your tummy? None. No. Okay, well, you buy a whole bunch of Jolly Ranchers and now you've got $90 and you've got, 50 Jolly Ranchers in your tummy. This one's going down, your money, and your tummy is what did I do wrong? Is getting bigger as you do the same thing. I drew those wrong, sorry. Okay, so when this goes down, this one's going to come up. Yep, I drew the arrow the wrong way. Okay, so here, down to 50, and so maybe you've got 200 different pieces of candy down to nothing. Now you've got no money and you've got lots of candy. Halloween Eve, 400 pieces of candy. So what do we see here? The money in your pocket goes down, and as it progresses, the candy in your tummy goes up. If you have less candy in your tummy, we're not talking about digestion here, okay? We're just talking about getting the candy. At the point that you have less in your tummy, you have more in your pocket. So one of the indicators goes up, the other one goes down. If you've got more goodies to buy, then you've got less in your tummy. So again, and that when it's mapped out, that will be a negative slope. And just like the one on the dog food we saw was a positive slope. So if you were to graph this out, it would be like pocket, and it'll come down like this. Okay? All right. Let's talk about another little item here, and that is zeros of functions. Okay? We've talked about it before. We'll talk about it a little bit more now, and it's probably not going to go away anytime soon. So zeros of functions. Remember, when an equation is written in function form, it would be like slope-intercept form, but we would usually use the term f of x instead of y. And to find the zero of a function, f of x would be 0. That would be the zero of the function. It seems kind of backwards because we always substitute in the x and then get the y out. Put in the independent, get the dependent. But this one, that's just not what we're doing. What we're looking for, again, remember, this is y. If y is 0, then remember that that is the x-intercept of the function. So, for example, if we had f of x equals 5x minus 10, f of x, to find the 0, would be 0. And then it would be 5x minus 10. We would isolate the x to find out the x-intercept. Oh. This is the x-intercept. It's the point 2, 0. That's where it would intercept. See the point 0, 0, yes. And you solve it out. This is the same thing as y, of course. Y equals 0. Y equals f of x, and f of x equals 5x minus 10. Okay. It seems kind of backwards some of the times, but what we're doing is finding the x-axis, and we call that the 0 of the function. A reminder, when you're graphing it, particularly when you're looking at standard form, it's very helpful if you'd have a graph and you have a point here and say this is the point 0, 5. X is 0, y is 5. This is the point 7, 0. X is 7, y is 0. Clearly this is the x-intercept. Okay, this is the y-intercept. Remember, intercept means where it intersects the axis. So if we go ahead and draw this as a line, that's 2 points for the line, so we can use it to draw a line. If we do that, then what we see is the x-intercept with the 0. This is a 0 because it has a 0 in it. And this is an intercept because it crosses, but it also has a 0 in the coordinates. So that's what we're talking about. The 0 in it means it hasn't moved up and down if it's the x-intercept, if it's the x, and it hasn't moved left to right if it's the y. So if x is 0, hasn't moved left or right, the intercept is 5. If y is 0, it hasn't moved up and down, and the intercept is 7. Both of these have an intercept, and both of them have a 0. But what we do is we call one of them, this one, we just call the intercept. So if somebody just says intercept, the intercept. If somebody just says intercept, they mean this one. And if somebody just says 0, they mean this one. This is the 0. Okay? That's terminology. So we have 0 and we have the intercept. Now, sometimes something might be worded a little bit differently that you'll need to figure out what they're talking about, and you know that they both work and you can figure that out. Okay? So let's look at finding some zeros of some functions. How about this? Write it down in your cipher, and we'll do if f of x equals 7.5x minus 20. Okay? Well, we're looking for the 0. Find the 0. So y, or f of x, is 0. And from here, it's just rearranging. Make sure you rearrange it carefully. Don't always just do it in your head because it's so easy. The reason is I say that is because it really is so easy. And you'll make, just calculation errors. Okay, so x equals 20 over 7.5. Normally in algebra, we don't care about fractions. We actually sometimes prefer them. But remember that the rule is you can't have a decimal in a fraction. So you could write this as 200 over 75. I'll multiply them both by 10 so that there's no decimal. Now once I've done that, I see that those will both divide by 25, and I see that it will reduce down to 8 over 3. Now 8 over 3 is a perfectly okay way to do it as your answer. 2 2/3 is a perfectly okay, and 2.6 is perfectly okay, but except if you don't put the bar over the repeat bar over the 6, it's wrong. Normally, we'll just leave it the fraction because we don't usually care too much about that. So 8 over 3 works just fine, but any of those are acceptable as x. Okay, let's try another one. F of x equals 17x minus 68. Okay, again, we're asked to give the 0, so f of x is 0. If it said y, it'd still be 0. We just like the f. And reminder, again, I've said it multiple times, but a reminder, this is not f times x. It's a special algebraic terminology that has said the value of the function at x is. Okay? So, we start with 0. We just do the same thing to manipulate our terms. Okay, so 4 is the 0 of this function. Over here, 8/3 is the 0 of that function. Not a hard thing to do, but let's just remember that that's what we're doing. So here, I'd like for you to please work a few problems. I will put them here. I just did these two. So you do these two. These are the ones I just did. So do these, and I'll put the answer up. Pause it, work it, and then come look at the problems. If you have a problem with it, change it then to make sure you can get it right. Okay, go ahead and pause it. Okay, so now then, here are the answers and a little bit about how to work it. Okay, so this is finding the 0 of the function. And here endeth the lesson.